How's it going, everybody? I'm Driftwood. Welcome back to Learning GameMaker Studio 2. In this episode, we're starting a new project, so we have to go back to scratch, which is good to do periodically from time to time to reevaluate what you have learned and practice what you've learned. So we're starting from scratch again. I've already took the first step to handle the first part of the thing that we're going to be doing. So in this video, we're going to talk about using tileset collisions because it uses less memory than using objects for collision. It's a little bit harder, but it's not really that hard. After we go through this quick tileset collision tutorial, for those who are just looking for a tileset collision tutorial, we'll do that first. I'm going to pitch the idea for this game. We're calling it DriftBot. Well, I'm going to call it DriftBot, and I'll get into my pitch that I wrote up for it after this. So you got a brand new project, you don't know what to do yet. First thing we want to decide is what's the resolution that our game screen is going to run at. I mean, we could allow full screen or not, and we can have multiple resolutions, but remember, we're keeping it simple. We want to basically, make a lot of small demos before we put anything crazy into multiple resolutions. So I'm going to go with standard HD 1280 by 720 again. So that's the first thing I did, is I went to the room settings of the first room that was built in, renamed it to RM_tester and given it 1280 by 720. Second thing I've done is clicked up here on the game options and said, hey, we're definitely going to be running this at 60 frames per second. So I've changed the 30 to a 60 and hit OK. So after I've done that, I basically hit save and it kind of confirmed the project and it's stored my settings. But then we need something to represent the player. So before we just try to create crazy sprites or anything, we're going to use programmer art, as we've done in the past. We're going to make temporary sprites for the player, temporary sprites for basic collision and stuff. So we're going to right click on sprites and create a new sprite. And once you create your sprites, you have to think, or before you create your sprites, you really have to think about what size do I want my standard one by one tile to be. And it'll play into the size of the screen as well. If you're going with like a very small screen, like 320 by 180 or something, then you could go with like 16 by 16 tile sets. If we're going full HD, we could have bigger pixel densities. So I'm going with 64 by 64 tile set size. So we're going to create the player in a 64 by 64 size. So we can adjust the size right here by clicking resize the sprite and selecting whatever width and height we want and hitting apply with that. And we're going to call it SPR_player, or whatever you want to call it, whatever naming convention that you found works for you. I just usually use this one, and then after, if I was going to say player sword or something, I would do camel case as if I was doing JavaScript stuff after that. So we're going to set the alignment to middle center. We're doing a 64 by 64, double clicking here. And you can do something as simple as selecting one color and then selecting this tool and making it a complete box. I've just put this little line and then the circle tool, and I made a P for player. So this is our temporary programmer art for our player. It doesn't need to be animated. We're going to take it out anyway. We're just using it as something to represent the player for now. Hit X, it'll save it. Next thing we want to do is basically create a sprite for our collision tile set. So we're gonna make a tile set collision. So we're gonna go to our tiles layer here, and we're gonna click on create new tile layer. This is gonna be above the background but below the instances, and it'll also be right next to the tile layer that's going to represent the map on the. We're gonna use a tile set. We'll probably try to create one of our own, but we'll also look for some free ones online. So we're gonna create another sprite. Call it SPR_ sprite tile set or collision tile set or whatever. I'm just calling it SPR_call for collision. Now you need to make the width on this sprite that, like if you were talking about 2 tiles. So you're going to make it the height of 1 tile. So if our sprites are 64 by 64, we want the width to be 64 times 2. Because when we're talking about tile sets, the first top left, the top left tile that's going to be whatever resolution, in this case 64 by 64, so the first top left 64 by 64 pixels is going to be used as a see-through, as a transparent tile set. So it has to be blank. So basically we're creating this box if we're creating just this box for a collision, but we need to create the double the width. So we'll create we'll click on size and uncheck maintain aspect ratio. That way you're allowed to change one without it affecting the other, and double the width of whatever height. So if you're going like 32 by 32, which is perfectly fine, you'll do 64 width and 32 height and hit apply. Then double click, and we're going to keep the alignment on the top left because it won't really matter. We're going to use the sprite as a tile set. We're not directly going to draw it on the screen. So basically just select this box tool, and you can turn on the grid if you need to basically get your box perfectly split in half, so that you have the left half completely transparent and the right half just mostly transparent with some lines to represent this is going to be a collision box. Really simple, doesn't need any animation. So once we've done that, we're going to right click on tile sets and create a new tile set. So when you create a new tile set, it's going to ask for a sprite that you want to use for the tile set. So we're going to click on the three dots and select the SPR_collision that we've selected for our sprite set. Now we need to go to the tile properties and select what resolution we're using. So remember, I went with 64 by 64, so I'm going tile width 64, tile height 64, and then the borders of 2. But you can set this to whatever you want and mess with the numbers that you want. What if I were to change this to 1? How's it going to look? It won't really matter too much. Basically, just set the tile height and the tile width to match the resolution of the game. See how you see how that this is only two tiles, right? So what's cool about GameMaker Studio 2 is you could have multiple tile sets used at the same time. So basically what we're going to be doing, we're going to draw this on top of another tile set. So we'll have above the background layer another tile set layer, which we'll get into in another video, and then the collision layer will be on top of that. And we're going to basically double click on this and hide all the collisions, so that the things that we draw, instead of using objects for collisions, we're using an invisible tile set. So in the editor we'll be able to see it, but then when we go into the game you won't see it. So that doesn't matter what you make the box look like. You just want it to represent something that will be visible, because we could always turn it off. So once we've got that, all we're gonna do is create our player. We need to create basic movement. So we've got our map here, and basically we're going to have to create, we could use the tile set layer to draw. If we go over here and click on resources, we could click on our tile set and basically draw with this. But what we need to do is basically create our object player and get the basic movement, the movement structure set up. So that's what we're going to do now. So we'll double click on or right click on objects to create a new object and assign it the sprite that we use. So we're going to say sprite player or whatever you called it. We're going to set up a base speed, give it whatever you want. The higher your resolution of your game, the higher your base speed. It's an arbitrary number though. We're going to set up a temporary variable, call it variable layer ID or layer. Or you can't use layer because it's built in, but you can use like just call it layer ID and set it to layer underscore get underscore ID. And then this is going to be different for you depending on what you called your collision layer. So you can right click this and rename it to something different if you want to. But whatever you call it here, verbatim, capital sensitive, you want to reference that in double quotes and then in the parentheses and an end line. Then we're going to say tile ID, we're creating a variable but not a temporary variable because we're going to reference it later. We're going to say tile ID equals layer underscore tile map underscore get underscore ID, and then we're going to put in the name of this temporary variable, layer ID. So we're basically getting the tile map ID of whatever's on the collision layer, if that makes sense. Now what we're going to do is we're going to use some, we're going to create variables to get the bounding box of this, of every sprite, and when we're moving around of the collision sprite. So we're going to create a sprite underscore bounding box underscore left. You call it whatever you want really, and say set that equal to sprite underscore get underscore b box underscore left. And you don't have to put it in this order, you just need to get top left and bottom right. And basically we're going to use the sprite index. We could actually reference the sprite itself, but since this is using the player sprite, we could just say sprite index. So whatever, you know, we're looking for the bounding box of the player. So we can say the bounding box of whatever the bounding box is set up for the player sprite itself. And if we look at that, we can change that right here by using the collision mask. And we can change it right here if you want to set it. It's set to automatically, but you can set it to full image or manual. You'll probably end up changing it later. That's why I wanted to go over how you change the bounding box and how you change the collision mask. Alright, so back in here, we need to subtract the X offset for the left and the right, and the Y offset for the top and the bottom. I'm going to zoom in real quick, and I know this helps when I'm looking at certain tutorials. If you want to pause it here, copy this for the create. Alright, once you've got that down, you can click on the next thing. We're going to right click, or we're going to add an event, add the step event. Now remember, the step event is going to happen every frame of the game. So I've done several different methods to get this to work, and I've found that this is the best method for what I needed to do. And you may find a different method, but I like this method, and maybe it'll be perfect for your game too. So what we're going to do is we're going to declare some temporary variables, because we're going to use these to dictate the difference in the change in X and the change in Y. And then we're going to actually change that to set it to our move speed later on. So we're going to say variable X move equals 0, variable Y move equals 0. That's just declaring them and initializing them, saying, hey, we're going to use X move and Y move, so don't crash when we call them. So then what we're gonna do is we're gonna get some keyboard inputs. So you can use virtual keyboard right here. You can do keyboard underscore check underscore or keyboard check. It'll look like let's see this, keyboard underscore check, and then you use VK underscore up or something like that. Yeah. So if you want to check a virtual keyboard, like to see if you're pressing up, you would use VK up, and if you middle click on this, you'll get a bunch of commands which you can use. So you can use virtual keyboard for control, alt, backspace, a whole bunch of stuff, right? So middle mouse click will give you the quick jump to the help file to get more information on it. So you don't have to use WASD movement like I like. You can use up, down, left, right. You can even use a gamepad, but that's using GP face something. But we'll get into gamepad in a separate tutorial. So what I'm using is just WASD movement. So I'm using, if we're pressing A, then X move, subtract, move left. So that's going to be, because how it works is X, as it goes toward the right, you're going to add to your X axis, and the Y axis is going to add as you go down. So going up will be subtracting Y, going left will be subtracting X. So if we press A, we want to move left, we're going to do X move minus minus. That means we're going to take this variable, whatever value it is, subtract 1 from it per each frame that you're holding the A button. You're going to do copy paste that and do one for up down, or up down left right, and then remember X move is going to be left right, and Y move is going to be up down, and as you subtract from Y you go up, and as you add from Y you go down. Okay, I think I covered that enough. So now we're going to look at a way to reduce our diagonal move speed, because if you're adding to the X and adding to the Y at the same time, you're going to move diagonal quite a bit faster than if you were just moving down and then to the right. If you're moving down and right at the same time, it moves faster than it should. It's not, so we need to cap that. So basically we're going to create a temporary variable. We're going to say variable move speed equals base speed. Now we're referencing what we declared right here. That's why we didn't use this as a temporary variable, because we're referencing it later. So we're going to say this temporary variable is now set to, this temporary variable, we're declaring it and set it to the value of base speed that we put in here. You could bypass this, but if you use a slightly different method, but I like this method and you should probably do it. So we're going to say if X move does not equal 0 and Y move does not equal 0, then set move speed to equal base speed times 0.75. This is going to change our speed if we're moving diagonal. This is going to cap it so that if we're moving diagonal, it's not going super fast. And that means it's going to move, if you're moving down and to the right, you'll get there at the same time as if you move diagonal. So you can optionally exclude that if you don't want it. If you want to move super fast when you're diagonal, unrealistically, you can just exclude it. But it keeps your game balanced probably. So we're going to check the horizontal collision detection, and you want to check it in this order. You want to check the horizontal collision and then the vertical collision, or you might have some problems. So you're going to use this. You're going to say X, which is just the location of this sprite or this object. We're going to say X plus equals X move times move speed. So this is the formula we're going to use to control how we change our X value. And instead of using else handlers, which I did before and had some problems with, I got rid of the else handlers and looked at a different method of doing this and just used separate conditionals for each direction, and it works better this way in my opinion. So we're going to say if X move is less than 0, then this is when we're going to move left. We're going to create a couple temporary variables for our collision point, tile point 1 and tile point 2. So variable t1 equals tilemap underscore get underscore at underscore pixel. And here's where we're going to reference our other variables that we created to get the ID. So remember when we selected, we created a temporary variable right here, the layer ID, and then we assigned it the tilemap get ID of this layer ID to a variable called tile ID. This is why we needed to do that, so we can get tilemap get at pixel that tile ID. And then we're going to use the bounding box right and the bounding box top of this object itself. And then we're going to say, this is something that in the help file they reference, and this is, there's another method to go about this, but this is like the short and sweet, easier way to do it. So you just reference that and you include tile index mask. So you're going to say variable t equals this and tile index mask. And you're going to do that for all the collision checking. So basically for moving left, you're going to do bbox left, bbox top. And you're going to do the same thing, but you're going to say bbox left, bounding box left, and bbox bottom. So basically we're checking both sides of the left side, but the top and the bottom. So we're getting those 2 points will be values. So we're going to say if t1 is not 0 or t2 is not 0, then x equals, we're going to put a double parenthesis at the start. We're going to say bounding box left plus 64 if you're using 64 by 64. Now remember what I said at the beginning, we need to figure out what resolution we want to set our tile sets to be. Well, this is going to be 64 by 64 for me. So if you're using 32 by 32, these numbers will be different. So if we're using 64 by 64, you're going to add 64 to it because it's from the left. Then we're going to say and a complement of 63. We're going to say whatever our resolution is. Now the tile set resolution will have a bug if it's not a power of 2. This method of and complementing of the number -1 will only work if it's a power of 2. So you have to keep that in mind. It's got to be a 16 by 16, 32 by 32, 64 by 64, 128 by 128, and so forth, so on, right? So this will work for all of those that I aforementioned. So for me, it's 64 by 64, so we're saying and a complement of 63. If this was a 32 by 32 tile set, you would say plus 32 and a complement of 31. Does that make sense? We're going to subtract sprites bounding box left, and we're going to next we're going to do the same thing basically, but the x value will change differently if we're moving right. So that's it for the first condition, moving left. For moving right now, we're going to say x move if conditional, if x move is greater than 0, then we're going to move right. Do the same thing, you can copy paste it, except you need to change the left part to the right part. We're still checking top and bottom, so we're just checking, instead of this side, we're checking this side. Now we're going to say another conditional inside this condition, saying if t1 does not equal 0 or t2 does not equal 0, then x equals bounding box underscore right, this time, and complement 63 if you're using 32 by 32, complement 31. And we need to subtract 1 so we're not pushed into the tile set, and like it'll throw you off the screen if you do that. If you don't include the -1, you'll actually collide with it and get thrown all the way off the screen. It'll just push you all the way up. I've bugged out and done that before. Subtract SPR underscore bbox right, and then that's it for the conditional. Now, after we've done the horizontal, we're going to check vertical collision. It's the same thing, basically, except we're checking something slightly different. We're just going to reference the tops and the bottoms and use y instead of x. So, this case for vertical, we're going to say y plus equals y move speed times move speed. And we're going to say if y move is less than 0, we're going to move up. Variable t1 equals, copy paste it, but change this part right here, so that we're checking left and right and just the top. And then we're going to do if t1 does not equal, copy paste that as well. And when the change, we're going to say y equals bounding box underscore top plus 64 and a complement of 63 minus the sprite's bounding box top. Remember, these are variables that we created on the create step right here. And then you can copy paste the whole thing basically. Change this from top to bottom for the bounding box. And everything is the same except right here it's different. We're going to say y equals, when we're moving down, bounding box underscore bottom and a complement of 63 if you're using 32 by 32, complement and complement 31. If you're using 16 by 16, you would and complement 15. That makes sense. You're going to subtract 1 so you didn't get pushed into the tile set itself. And subtract that by the sprite's bounding box bottom. And that's it. Now what I'm going to do is If you missed any of that, I'm going to zoom out a little bit and try to get this whole thing in one. Come on, scroll up. Scroll up. You can do it. Okay, here we go. That way you can copy paste it if you can get a good look at it and copy it. Pause the video if you need to. I guess I'll have to zoom out one more. Boom, there you go. So that's the whole thing. You can pause the video here if you missed anything or if you want to double check what you've already got down. So that's it right there. Oh, shoot. There we go. We'll get it. We'll get it. There it is. That's everything. So you can pause the video. You can declare your variables, check your inputs, reduce your move speed for diagonal, so forth and so on. It's pretty much like once you get this first conditional, you can copy, paste, change a few things. Just make sure that you get the left, left, right, right, and then the top, top, and bottom, bottom, that you're checking the bounding boxes. And if you get it all set up right, everything should work fine. And then once you've got that set up, you're going to go to your map. And basically, you're going to draw. You're going to use your tile set. Go to the room editor. For right here, go to the room editor, and under tiles, you're going to be able to draw transparent to erase, or you're going to be able to draw the collision box. And this is going to let you draw some collisions so that you can. This is a blank map, right? But if you were to have your tile set and you say you have a house right here, you can put a collision right there, but you want the door to be right there and walkable, so you would let the door go right there. So that's how it would kind of work. So, yeah, let's go ahead and do that. And we'll play test it to show you that it works. So I'm using WASD movement, but whatever you're setting up to use, you can use arrow keys or whatnot. So if I press left, we're able to collide into these boxes, but we're not, it's not tripping out, because if you don't do the subtract 1, you go boom and you fly off the screen. That's why I did a failsafe when I was testing things. You can see we collide perfect. It is pixel perfect, and it doesn't use near as many resources as using objects for collision. So it's a great way to do it. I recommend using this method of Tileset collisions. And this is basically just getting started. So we've got temporary sprite art for the player, and we've got basic movement functionality, and it doesn't go super fast when we're doing diagonals. And we've got collision detection set up perfectly. So that's basically going to be it for this tutorial. It went a little bit long, but it's the first episode in a series that's going to be a pretty cool game. And I got a pitch for you here. Let's go ahead and let me minimize this, and I'll bring it up. And let me give you my pitch on the game. So this is the game that we're going to be creating. It's going to be a demo. It's not probably planning to do hopefully a little bit longer than the last demo. The last demo was like a 10-minute, and then you're bored and it's done. I'm hoping for a 30-minute demo with this game. Here's the idea. This is going to be called DriftBot, and this is a game where you play a drone sent out into the universe to drift the emptiness until you reach your destination, which would be an uninhabited planet that you've been sent out. You're equipped with seeds of life, the basic supplies to build greenhouses, and you're tasked with cultivating and terraforming a planet in an attempt to make it a new living world for people who are doomed on a dying planet. So your objective is to go before, they've already left the dying planet, but they've sent out all these bots to different planets to try to terraform them beforehand. So by the time that they reach their destination, hopefully one of these planets that these drift bots have gone to will be inhabitable, so that the species can continue to go to move their life from one planet that's dying to another planet that's built. You have to build the atmosphere for it, basically. So your objective is to grow plants and wildlife all over the planet to eventually be the cause of a habitable atmosphere by the time the settlers arrive. You'll land on a planet, set up a greenhouse, and start growing wildlife. Will you be able to save the future for your makers? A huge task for such a small drone. So you're going to control DriftBot to save all of humanity by building greenhouses and growing plants in order to create a habitable atmosphere. The future of an entire race is in your hands. So that's the idea I thought of. I thought it was pretty cool. It's going to basically be a farm sim, but different than like your typical Harvest Moon, Stardew Valley type thing. It's going to be completely different. It's not like a relationship sim. It's more of just a technical farm sim where you have to build greenhouses and grow wildlife and manage the atmosphere and the O2 levels or something, and try to get the planet to become habitable for the future of mankind. So that's the idea. wrapped up in a collision detection tile set tutorial. Hopefully you guys are excited about this new series. Thank you guys so much for watching. If you enjoyed this tutorial, please give it a thumbs up. If you have any special requests for this game, or you know, you need help with GMS2, I'm still learning myself, but I'm having a ton of fun and I've learned a lot so far. So please let me know if you have any special requests in the comments below, and I'll try to help you the best I can. And thank you guys so much for watching. Thank you for everybody who's subscribed to the channel. If you're not subscribed, consider doing so. I've got lots of tutorials for RPG Maker MV. I've got some tutorials for GameMaker Studio 2. And I do first impression videos. So if you make RPG Maker games, or if you make GameMaker games, you want me to play them and advertise them for you, let me know. Not every game that I get sent actually gets a video, but a lot of them do, and it's basically free advertising. Social Blue Book says I should be charging 160 bucks for it, and I basically do it for free. So it's an opportunity if you want to advertise your game that you can hit me up. It won't always be the case, and it won't always be like this, but for now, it works for both of us. You know, I get content, my viewers get content, and you get free advertisements. So let me know if you want your game to be played. I'm not going to sugarcoat it if I don't like it, so keep that in mind before you show the world something that might be critiqued, because that's what I'll do. But thank you guys so much for watching. I know this tutorial ran on a little bit long, so we're going to cut it right here. You guys are awesome. We'll see you guys in the next tutorial. Bye-bye.